show you a proof that's a little easier than the method of induction.
Is this 4 point?
It's 4.2. So let's let S equal the sum 1 plus 2 plus 3 plus 4 plus dot 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 plus n minus 2 plus n minus 1. In other words, it's the sum of the first n integers. You guys all agree that that's true, right? I think it was Gauss, when he was 10 years old, he was in this high-level, math class at some university, and of course the professor was a little bit intimidated, this little 10-year-old. 10-year-old knew how to do everything already, sort of. And one day, to get the kid to shut up, he said, all right, go to your desk and add together the first 1,000 numbers. And he thought that'd shut the kid up for a few minutes, or for quite a while. And the kid came back in 1 minute or 2 minutes and said, here you go. And he invented this formula at that time. So if you really need to add the first n numbers, you don't have to add them up. You can just take whatever n is and plug it in there. So for example, if I, to shut you up, said add from I equals 1 to 1,000, the i's. In other words, take 1 plus 2 plus 3 plus dot 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 plus 999 plus 1,000. What you would do instead is plug 1,000 into the right-hand side here. 1,000 times 1,001 all over 2, which is 500 times 1,001, which is this. So you don't actually have to add the numbers. You can do that instead. Let's prove that this works. I can add in any order, right?
Yeah. Yes.
So if I decided to write this sum S in a different order, if I decided to put n first, and then n minus 1, and then n minus 2, and then n minus 3, dot, 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 and end up with 3 plus 2 plus 1, that wouldn't bother you, would it? I mean, you're going to let me add in any order you want, right? Because you're generous folks. Very kind of you. What do I get if I add S plus S? Very good. What do I get if I add 1 and n? 1 and n. I get n plus 1, don't I? Plus, what do I get if I add the next two terms together? Really? And what do I get if I add the next two terms together? Really? And what do I get if I add the next two terms together? Really? Plus dot, dot, dot. What do I get if I add the third to the last two terms together?
N plus 1.
Well, look at that. And these two, n plus 1, and these two, n plus 1. Isn't that amazing? How many of those were there? See the blue? N of them. Very good. So 2s is equal to n times n plus 1, or the sum s is n times n plus 1 over 2. Okay? So here's the formulas, and you can prove these others in a similar fashion. But you're supposed to, on the next test, be